All right, so let's get into doing some finding inverse function equations given the original function. So there's 3 steps. You're going to write it with y instead of f of x, then you're going to interchange x and y, and then you solve for y. So our first example is f of x is 3x minus 5. Now again, these are inverse functions, meaning they should undo whatever the function does. So this function, you plug in a number and you turn the function crank, and the machine is going to multiply by 3, subtract 5, and then spit out your number, right? So whatever my inverse is, I would like it to undo those operations. Now, this is a line with positive slope and a y-intercept of 0, -5. So I already know what this looks like. So I could actually make a table of values, plot some points, and then I could graph the inverse because I know that they're symmetric. And it would be just like the very, very first problem we did in this section where I just gave you a couple points. So let's go ahead and do this problem. So instead of f, I'm going to write y. Now remember, y and f of x are the same thing. It's just function notation versus equation notation. Now I'm going to interchange x and y and solve for y. So that means I write x is 3y minus 5. I add 5, and I divide by 3, which is exactly the opposite of what my original function did. So my original function, so f takes in input, multiplies by 3, subtracts 5. My inverse adds back that 5 and then divides by 3. So it does the opposite steps in the opposite order, right? Socks, shoes in the morning, shoes, socks at night. Okay? If you want to write this as 1/3 x plus 5/3, you can do that, but it's okay to leave it like this as well. So our inverse is x plus 5/3. Now I did go ahead and graph each of these just as an illustration to show you guys. You weren't asked to graph them, but I wanted to. All right, so the blue is my f and the red is my f inverse. So they are symmetric about the line y equals x. You can see that would be this line here that I didn't draw, and actually I could go ahead and draw that in. Let me do that. And actually when I did this, I graphed the blue using point slope, and then I just, well, blue has the 0.21, so red would have the 0.12, and I plotted that point. Blue has the 0.34, so red has the 0.43, and I actually did that, and that's how I made my inverse function graph. So something to note, the slope of my original, remember slope is y over x, the slope was 3/1, so when I interchange x and y, I'm going to flip my slope. So instead of y over x, it'll be x over y. Instead of 3/1, it's 1/3. So instead of 3/1, which is up here, it's 1/3 down here. All right, and that's exactly what we have. We have a slope of 1 up 1 over 1, 2, 3. What else? This blue has a y-intercept of 0, -5, so that means the x-intercept of my inverse function is -5, 0. So y-intercept turns into the x-intercept. So that is our first problem. Again, the graph was not part of the instructions. The instructions were just to write this equation. So you interchange your x and y and solve for y. My f multiplies by 3, subtracts 5. So my inverse f adds 5 divides by 3.